sklearn, base, clone. Description. The clone function in sklearn, base creates a deep copy of an estimator. This means it creates a new instance of the estimator with all its parameters and attributes, initialized to the same values as the original estimator. This is useful for various scenarios like hyperparameter tuning. Cloning allows you to create multiple copies of the same estimator with different parameter settings for exploring the search space effectively. Ensemble methods. Techniques like bagging and random forest involve creating multiple copies of the same base estimator, each trained on a different subset of the data. Pipelines. When building complex pipelines, you might need to clone estimators to avoid unintended modifications to the original estimator. Inputs. Estimator: an instance of an estimator object, e.g., a classifier or regressor that you want to clone. Outputs. Cloned estimator: a new instance of the estimator, completely independent of the original estimator. Any changes made to the cloned estimator will not affect the original one. Steps. The clone function utilizes the copy, deep copy function from the Python standard library to recursively copy all the objects within the estimator, including its parameters, attributes, and nested objects. This ensures that the cloned estimator is a complete and independent copy of the original one, with no shared references. Metrics. Accuracy. This metric is used to evaluate the performance of the cloned estimator on a classification task, measuring the proportion of correctly predicted instances. Precision. This metric measures the proportion of correctly predicted positive instances out of all instances predicted as positive. Relevant for imbalanced datasets. Recall: this metric measures the proportion of correctly predicted positive instances out of all actual positive instances, highlighting the model's ability to identify true positives. F1 score. This metric combines precision and recall into a single value, providing a balanced measure of performance. Visualization plots. Confusion matrix. A visualization that shows the counts of true positives, true negatives, false positives, and false negatives for a classification model. ROC curve. A plot that shows the trade-off between the true positive rate sensitivity and false positive rate 1 specificity at different thresholds for a binary classifier. Precision recall curve. A plot that shows the trade-off between precision and recall at different thresholds. Helpful for imbalanced datasets. Fine-tune parameters. None. The cloning process itself doesn't involve tunable parameters. Fine-tuning is done on the cloned estimator based on its specific hyperparameters. Uncertainty methods. Confidence intervals. These provide a range of values around the predicted output, indicating the uncertainty associated with the prediction. Bayesian methods. These approaches incorporate prior knowledge and update it with observed data to estimate the uncertainty in predictions. Challenges and fixes. Challenge 1. Deep copying complex objects with circular references can lead to infinite recursion and errors. Sample use case that resulted in challenge 1: a custom estimator with nested objects containing circular references, creating a loop in the copy process. Fixes to challenge 1. Check for circular references before cloning. Inspect the estimator structure for circular references. Use a custom deep copy implementation. Implement a custom deep copy function that handles circular references appropriately. Challenge 2: cloning estimators with mutable objects, e.g., lists. Dictionaries can result in shared references and unintended modifications. Sample use case that resulted in challenge 2: an estimator with a list of features that are modified during training. Cloning might copy the list by reference. leading to changes in the original estimator. Fixes to challenge 2. Use immutable objects wherever possible. Use immutable objects like tuples to avoid unexpected modifications. Deep copy mutable objects explicitly perform a deep copy of any mutable objects within Pay. Estimator before cloning.